Okay, it's loading. We are live now.
We're live. Hi, everyone. Welcome to the final lesson, educational lesson of the year for 1000 Faces. I'm Marlene. Happy to be here with all of you. It's been a nice year of lessons, of taking new information in, understanding different concepts. So I'm happy you are still on board. Today we're doing the part 3 lesson for blockchain. We are finishing the year strong with trying to understand and make sense of this blockchain. And at the end of the lesson, we will give a wrap up of what we've learned so far this year. And yeah, like this, we can take time to process what we've learned this year, and we can start next year with a fresh mind, and we can continue our educational learning. So let me share my screen with you. Great. So this is the wrap up for blockchain, the part 3, and a summary of 2020 lessons. Let's get started. It went directly to this page. Okay, yeah. So I will do a quick recap of what we've learned in the last lessons for blockchain. Like this, you can get all this information and we can dive today. So we already looked at a few definitions of blockchain. We looked at the origin of blockchain, knowing how it was created. In fact, one of its uses, Bitcoin and cryptocurrencies, was the origin of creating this technology that is so helpful for today. And we've seen different ways in how this technology will be used. And we looked at 5 properties of blockchain. So it's distributed, encrypted, historical, immutable, inclusive, and transparent. So this is what we've seen in the last part 1. And on part 2, we saw an example of how transactions are using the blockchain technology today, why it's important, and how it's done through what we call the distributive public ledger. So we saw how the scenario where 2 friends are making a transaction to the third friend, and after I explained how these transactions are encrypted and why it makes this system secure. So let's dive today into the lesson today. Keep in mind this example because how we explain this distributed public ledger and the security mechanisms behind it. I will go into a bit more technical of how that is created. So keep this example in mind. Let's dive in. So today we will look at concepts that you've probably heard of, proof of work or POW, proof of stake or POS, and then we will do the final wrap-up lesson. So as you've probably seen in the Web3 and the crypto world, there's a common use of using acronyms and the short terms for some words. So that's why I'm trying to help you to get exposed to some of these terms. Like this, when you see them, if you know what we're talking about. And normally we will put in the educational hub in our Discord a list of the most common use terms. Like this, it's easier for you to go back to it and refer to it when you're reading an article or you're finding more complex information. It can be easy for you. So what is this proof of work? Proof of work, as we remember with the blocks that the transaction has for the different friends, It's a way of adding new blocks of transactions to a cryptocurrency blockchain. So in proof of work specifically, you have some people, that are behind the computers called the crypto miners. And the crypto miners compete with each other to win the right to update the blockchain and receive the rewards. So when we have, in the example where we have a transaction, and we will have new blocks coming in, which is happening all the time, the crypto miners are the ones who are in charge of updating this blockchain. So what are these rewards? Why are the crypto miners so interested in being the first one to update this? The rewards are the newly minted crypto coins. New projects are coming into the blockchain, so there's birth of new coins all the time. So they are very interested in getting ahead of the game and getting some of these crypto coins at the value where they can at the lower value when they're entering the chain, and they can have part of the transaction fees. So let's go back to I use one term, crypto miners. So let's look at what crypto miners is, what mining is. So mining is the method that is used in the blockchain to group transactions into a block, append this block to the blockchain, and broadcast the new block into the network. So this is what we've seen, that the friends have their own transactions, and because it's public, it goes back into a bigger network. So why is mining important? Mining is ensuring that consensus mechanism is maintained and keeps the blockchain decentralized. So this last phrase is it's kind of the purpose of proof of work. It's a consensus mechanism that keeps the blockchain decentralized. It keeps it, and it keeps a mechanism that keeps it safe and keeps the same mechanism going. So it's not, it cannot break down. So if we understand that, we can look at this diagram now. We have a transaction. So imagine the friends are paying each other the transaction that they had to do. So there comes the miners that I've been talking about. So as soon as a transaction is made, there's blocks created, and the miners are the first trying to have this, trying to find these blocks. So it's like a block, but we know it's mathematical data, so it's like solving a puzzle. And this is where the proof of work comes into place, where it goes into a mechanism to keep these new incoming blocks into the network on the mechanism. So the miners are verifying these new blocks, incoming blocks into the change coming, and it goes back into a system. So it's a cyclical system. It's a bit hard to understand, but basically, as we say, a transaction is happening between two people. And when it goes into a larger network, it's a mechanism to keep the network functioning in a safe and mechanistic way. So if we keep this in mind, how do the miners find these blocks? You know, you can imagine a transaction has a lot of numbers, has its own algorithm. So how is this happening? So the proof of work blockchain has a mining algorithm, or what we know as hash. You will hear this term often in the blockchain, hash, cryptographic hash. And these functions to take place, it's a way to have the hash. I will explain what hash is. So let's move on to the next slide to make it clear. So a hash, you can imagine on this diagram, it's a transaction between two friends, and there's an algorithm created. And blockchain has so many utilities. You can have algorithms created. We call this input, and the input can be as simple as a few characters, or it can be as complex as millions and millions of characters. So the input itself that is coming for a block, it has no limit of how big or small it is. However, we need to find a way to make all the inputs to be identifiable despite its size. And this is where the hash comes. So a big or a small input comes in and there's a hash created. So in simple terms, a hash means taking this big input or small input, and you create a string of characters, and it's always the same length. And then the output, so the output is the hash itself, and it's always the same length. So it's a way to simplify the complexity of transactions happening in the blockchain. So maybe I will just explain it using this diagram. You have a transaction made. It can be a big or small transaction, and it comes to be created into a block to be integrated into the blockchain. And so this input gets created into a hash. And then the hash, it gives an output, and this output is always the same length. It doesn't matter which is the input. The hash is always the same length. Like this, it's very easy to identify the hash. So if we have this here, so this is the hash, and the miners will use this same size of hash to identify which blocks they have to mine. So let's move on to the next part. As you see in this diagram, we have something particular here that says SHA-256. SHA stands for Secure Hashing Algorithm. And this one is very known because it's the one that Bitcoin is using. And the particularity it has is that it's the output, so that meaning the length of the hash is always fixed to 256 bits length. So these are, we can call them specific algorithms for each cryptocurrency. Although different currencies can share these algorithms. So Bitcoin is known for using SHA-256. Ethereum has been known to use Ethash or Dagger Hashimoto Kekak, its specific names, but you will hear about these names. And there's other hashing algorithms that have been created because so many cryptocurrencies have been born. For example, we have the hash of script, we have kryptonite, etc., many others. So this is just for you to understand that the important point, each cryptocurrency can use its own hash, but the principle of how the hash is working is the same. So I mentioned here some of the main cryptocurrencies, Bitcoin, Ethereum, and we will move on to a different concept. So this is proof of work and how it's working. I will now explain proof of stake, and then I will relate it back to why it's different and similar to proof of work. So you will be able to understand. So proof of stake is also a consensus mechanism, just like proof of work. And it's used to validate new entries in a distributed database. So the same purpose as a proof of work, and keep this data secure. A blockchain being this distributed database, a consensus mechanism is used to secure this blockchain. This is done. So, as I said, proof of stake was developed as an alternative to proof of work. So they have the same principle, but it was developed after proof of work. So, as you may have heard, this year in 2022, there was the Ethereum merge. And this is something that caused the birth of, maybe what didn't cause it, but it was one of the factors that made the transition between proof of work and proof of stake. So when the Ethereum merged in September 2022, Ethereum is going to change by its system of consensus mechanism for the blockchain from proof of work to proof of stake. And some particularities about proof of stake is that it chooses a participant on a blockchain to perform the task of validating new entries and adding new blocks to the chain. So we already hear a difference between proof of work, because proof of work, we know that there's the miners who are trying to catch the new incoming blocks. However, here we have the proof of stake. They already choose the participants who are going to validate these new oncoming blocks into the blockchain. And we heard about the crypto miners in the proof of work trying to catch the rewards of the new chains. In proof of stake, the users get rewarded once they've done the job successfully. The job successfully means when they are validating the block into the bigger network of the blockchain. And normally it's the same type of reward as a proof of work, meaning the blockchain's native crypto coin. So let's look now at a diagram to explain the similarities and difference between proof of work and proof of stake. So proof of work, as I mentioned, is you have the miners, and the capacity to mine depends on the computational power. And the reason why this is important is because, as we've heard, there's a big concern about the energy and electricity use of the crypto world. So this is important to consider, that for mining, it really depends on the amount of energy and computational power that is used. However, on proof of stake, the people who are, or the users who are validating, depends on the stake in the network. So this is predefined before. The miners are trying to catch it. Proof of stake, it's predefined before. So on proof of work, the miners receive block rewards to solve a cryptographic puzzle. They don't have to, by using the hash to find the hash, they're kind of trying to find the lottery. They're trying to figure out these lottery numbers. That's why it's called a cryptographic puzzle. However, for example, they don't have to do all the mathematical computation to try to find these numbers. That's why they're using the hash. And in proof of stake, the validators do not receive block reward. They collect transactions fees. So it's a bit different. It's still a reward system, it's just a bit different. And in terms of hackers, in proof of work, the hackers need to have a very high computational power. And if they have very high computational power, they have higher increased odds of hacking the system. And however, on proof of stake, the hacker need to own most of because the validators are predefined before they enter the blockchain. They need to be owners or be assigned the new incoming blocks in order for them to cause some malicious harm. So this explains some differences. I have another diagram to show. It's already 20 minutes, so I will hurry up. Yeah, so this is the same. They have a similar mining versus in proof of work versus proof of stake, which is a bit more deterministic since it's predefined. The hackers, we already talked about them. And there's some more competitional aspect to proof of work, as they're trying to solve the mathematical, find the lottery, while on proof of stake, it's a bit more cost effective since it's predefined. So yeah, it's two concepts. It's a bit tough to understand, but I hope like with this lesson, you can have some idea of how this is how it's working, because these terms are often used when we're describing. So putting together blockchain, what we've learned so far, we know it's decentralized. We know about its 5 properties. And we talked about how transactions are working using cryptocurrencies. And I explained the proof of work and proof of stake. There are still more layers to the blockchain. But for now, this is what we've covered so far. And just to wrap up this year, we will go over some of the main educational lessons for 2022. So yeah, we started understanding blockchain is a part of what we explained, and it's all coming together in a big puzzle. So some of the main things that we talked about was this introduction to Web3 world. So we saw that the internet has been evolving over time. Well, at the beginning, there was a very centralized focus. It was used to communicate from point A to point B. And there was always a central autonomy, different central autonomies that were controlling and managing the communication between users. Over time, it's evolved in Web 2 and now into Web 3, where the users have more freedom to communicate between themselves, communicate and connect between themselves. And Web 2 brought a lot of applications and uses about business development, how users are the main part of the internet, and it's become more volatile, and not volatile, but evolved into a lot of communication and uses. And now Web3 is bringing a lot of autonomy for the users themselves to communicate with each other and not have a central part in between them. So another big lesson of this year, as I said, it's the centralized versus decentralized. We've seen this in the Web 2, there was a central, and this was very important because something that came up a lot in Web 2 is to use Web 2 as a business model. So by having a central authority in the middle, there was lack of freedom for the transactions, and to make payment, to make business, you always had to go through a central server. And now the Web3 is transforming, and there is more peer-to-peer, and the way that the blockchain is built, it provides a lot more security. It's not foolproof, but it provides a lot more security for users to communicate with each other and to be owners of their own data. So after we went into a very fun topic that's part of Web3, it's NFTs. We looked at the birth of NFTs with different CryptoPunks, Bored Apes Yacht Club, Doodle Club, or World of Women, different revolution of how this NFT is working. We looked at some of the uses of NFTs, why they were created, and how are they transforming now We talked a lot about their utilities, their art, but they can also have utilities. And very cool how new projects are using them. And they are kind of membership cards in some ways. They have evolved for some aspect. They have evolved as membership cards into different projects, different ways that the Web3 world is revolutionizing towards. And we will see how these NFTs continue evolving. But yeah, this was a very nice part of the Web3 lesson. And we explain what NFTs are, meaning we looked at different examples in the physical world, the difference between fungible versus non-fungible. For example, fungible, it's a dollar bill. It can be when you buy a crypto coin, it can be has the same value for different users. However, when it's not fungible, like an NFT, it's like a piece of art in the real world. It's Mona Lisa. So yeah, we saw some of these different characteristics of NFTs. And we finished the educational lessons on blockchain. So this is it from my side and the Thousand Faces team. We hope you learned a lot. We covered a lot of topics. We looked at different definitions. And we hope you learned a lot. You take time to process this information, integrate it, and we will be back with exciting lessons for 2023. Thank you so much for your attention.